Hey folks, Mike Johnson here. If it's got wheels and an engine, you're in the right place. On this channel, we dive into car repairs, maintenance tips, and everything you need to keep your ride running smooth. If you're into cars and want to keep learning, don't forget to hit that like button and subscribe. It really helps the channel out. All right, enough talking. Let's get into it.
Still, warned shocks can be dangerous, especially during severe maneuvers that may be necessary to avoid an accident. As we shall see, for such a simple but effective device, shock absorbers seem to lack respect. The seriousness of the situation. Curiously, despite their name, shock absorbers don't absorb shocks. In fact, it's the work of the springs in a vehicle's suspension system. When a wheel hits a bump, the wheel moves upwards, compressing and storing the bump's energy in the spring. This compression is what absorbs the impact of the bump. But now that the spring is compressed, it contains potential energy that must be released. The spring does this by bouncing back to its original uncompressed length, while pushing the vehicle body upwards. In an example of the old adage, what goes up, must come down, gravity pulls the weight of the body down, recompressing the spring. If the shock absorbers are worn, the vehicle ends up bouncing off the road after each blow until all the energy is used up. In the worst-case scenario, this bouncing can actually cause a vehicle's tires to lift off the ground, rendering the vehicle uncontrollable. Bring on the shock absorbers. Shock absorbers, more correctly known as shock absorbers, are mounted next to, or inside, the springs at each corner of the vehicle. The job of a shock absorber is to provide resistance to the movement of the spring. Technically speaking, it does this by taking some of the energy used to compress the spring and transforming it into heat. So, whether the vehicle bounces off a bump in the road, this movement is controlled by the shock absorber and, once again, some of the kinetic energy released by the spring is transformed into heat by the shock absorber. This energy conversion prevents the vehicle's body from bouncing more than once or twice, ensuring controlled driving and helping to keep the vehicle's tires in contact with the ground. How do shock absorbers work? If you've ever waved your hand in water, then, in principle, you know how a shock absorber works. The resistance to movement you feel with your hand changes with speed. The faster you move your hand, the more energy it takes to push against the resistance of the water. A shock absorber works the same way. Inside the shock absorber is a piston that moves inside an oil-filled tube. As the piston moves, oil is forced through tiny holes and valves inside the piston, precisely controlling the degree of resistance to movement. This resistance to movement converts energy into heat. Yes, a shock absorber that's done its job on a bumpy road gets hot. Although there have been many different designs for shock absorbers throughout automotive history, today there are 4 basic types available: a twin-tube monotube gas-filled monotube external reservoir. Sometimes these types of shock absorbers are incorporated into a strut-type suspension which uses the shock absorber as part of the spring support, but the basic principles still apply. Twin-tube shock absorbers. The twin-tube design is the most common and often the least expensive. These are the ordinary shock absorbers that passenger cars and trucks use, and are widely available from car dealerships, auto parts stores and repair facilities. As the name suggests, in a double-tube shock there are 2 actual tubes, one the outer shock body and the other an inner cylinder in which the piston moves. Tiny holes or ports in the piston and special valves between the inner and outer tubes restrict the flow of oil to control wheel movement. The limits of twin-tube shocks become obvious when they are used on very bumpy roads. In this case, the rapid movement of the piston can cause the oil to overheat and foam, reducing the shock's ability to control wheel movement. The result is an increasingly sloppy ride, especially when traveling on a washboard surface. Heavy-duty twin-tube shock absorbers are generally stronger, with more robust piston pins and mounting points, and they can use oils that are more resistant to foaming, but they still have the same limitations. Single-tube shock absorbers. The heat generated in twin-tube shock absorbers tends to get trapped in the walls of the damper body, reducing its effectiveness in controlling wheel movements. The single-tube shock absorber uses a piston moving in a single tube that is exposed more directly to the air. The general advantages and disadvantages of this design are, by shedding heat more easily, single-tube shocks are less likely to overheat on rough roads. They are more expensive to manufacture, and tolerances must be higher and seals better to keep the oil inside the shock body. Single-tube gas-filled shock absorbers to prevent the formation of foam and bubbles in the oil, which degrade shock absorber performance. A gas-filled monotube shock has a high-pressure nitrogen chamber above the oil chamber. This high-pressure gas makes it difficult for bubbles to form in the oil, even when the shock is moving in and out very quickly, as it may do when moving fast on a very rough road or on a washboard. Gas-filled shock absorbers are expensive, as they require strict manufacturing tolerances, but they are highly resistant to fading. And, as a result, are popular in off-road racing and rallies. By the way, gas shocks are not the same as air shocks, which use an air chamber separate from the shock oil. An air shock is actually an air spring that raises or lowers the vehicle when air is added or removed through a valve. External tank dampers. The top of the line in shock absorbers is the external reservoir design. These shock absorbers, mainly designed for ultra-high performance and racing applications, use a small, lightweight shock body which is connected by a hose to an oil reservoir mounted in a different part of the vehicle. The purpose of an external tank shock is to reduce steering wheel weight for better handling, provide better cooling of the oil in the tank, provide a large airspace inside the tank so that hot oil can expand without blowing, seals, provide excellent adaptability. As oil flows to and from the damper body, external tank shocks are very expensive and only really necessary in extremely high-performance applications. When to buy shock absorbers? Shock absorbers last a long time, but they tend to degrade slowly over their lifetime. So when is it time to replace them? In some cases, a seal will break. An oil-covered shock is a good indication that it has failed. The age-old bounce test on a bumper is really a rough guide as to whether your vehicle needs new shocks. Usually, the slow degradation of your shock absorber's performance won't be noticed until it affects handling quite dramatically. Depending on the hardness of your roads, modern shocks can last between 80,000 and 100,000 miles, but remember that a 60,000-mile shock won't work as well as a new one. Shocks can be tested on a shock machine, but to do so, they must be removed from the car. With labor rates, if your mechanic already has the old shocks, it makes sense to replace them with new ones. Replacing worn shocks can revitalize a vehicle's handling and restore much of its freshness. When combined with a new set of tires, new shocks can transform a high-mileage vehicle with sloppy handling and a bouncy ride. Choosing shocks for your vehicle. Which shocks to buy depends largely on the type of vehicle you own and the type of driving you do. Shocks are available in a range of prices. Often, you get what you pay for. If you like the way your vehicle was mounted and handled when new, opt for original equipment replacements. If you're looking for more, there are a number of options, including heavy-duty shocks for carrying heavy loads and performance shocks for more precise handling. As with most automotive components, it's important that you buy the right shocks for your specific vehicle, as inappropriate shocks can significantly affect handling and could even be dangerous. The best advice will probably come from a mechanic who knows your type of car. Needless to say, if you make the right choice, the improvements in your vehicle's ride and handling can be shocking. In conclusion, understanding how shock absorbers work is essential for appreciating their role in vehicle performance and safety. By effectively managing the energy generated by bumps and vibrations, shock absorbers ensure a smoother ride and improved handling. Whether you're driving on smooth highways or rough terrain, these components play a crucial role in maintaining stability and comfort. Regular maintenance of your shock absorbers can enhance your vehicle's longevity and performance, making it a vital aspect of automotive care. Thank you for watching, and we hope you gained valuable insights into the fascinating world of shock absorbers.